So, hi. Have you had a good conference? Got some great inspiration and some insights? Yeah? I hope we will be able to give you some of that as well. We're going to tell you a story about getting started, about getting things going by engaging the organization, even though not all technical or organizational prerequisites might be in place. How to start small, build with what you have and what you can find, and produce some real value to get attention and traction in the organization. And here to tell you this story today is Julius, our Python developer and LLM whisperer.
And this is Maria Kalmér, jack of all trades, master of business value.
And Jörgen Andersson, creator of magic portals between worlds. This is necessary. The three of us come from Pensionsmyndigheten, Swedish Pensions Agency in English, a government agency where we have approximately 350 people working in IT. Our system sends us a lot of money, each year providing Swedish pensioners their main income. Of course, the hype of AI has struck us as well. We're no exception. Everyone wants to reap the benefits of AI and figure out what's in it for our organization, and of course, we're no exception. When the three of us started working together for the first time was in May last year, and we'd seen quite a bit of talk about AI and how we could benefit from it in our organization. But we hadn't seen a single initiative in making it all the way to production. And you know, it's when you hit production, the real value is created, both in terms of actual value that what we built delivers, but also, and perhaps foremost at the stage we're currently at, the learning really takes place coming up to production. And everything gets real in a whole nother way than some document or PowerPoint slides ever could be. And when we've been in production for some time, we start to learn from reality, of course. So before we dig into details of what we've done and what we've learned, Julius is going to give us some more context applicable for our business.
Yes, as a government agency, our operations are critical to the Swedish society. They have to be running at all times, and we must keep our data secure and correct. We also need to consider how operations can be upheld in times of crisis and even war. Therefore, relying on services that are located further away makes us more vulnerable to activities that are outside of our control. And using commercial cloud services is therefore most of the time not an option. This is also due to the fact that we cannot share citizens' pensions data or most other data with any such services. Therefore, if we want to gain real traction in developing AI-based services, we need to have them running in our own data center, on our infrastructure. And the infrastructure will be presented by Jörgen before we proceed with the rest of our story.
Yeah, I think technology-wise, you will recognize quite a bit. We're relying heavily on Java, no surprise being here. Lots of Spring and Spring Boot. We build mostly microservices, package them up in Docker containers. We use Apache Maven and Jenkins to test and deploy into test environments to production that runs on our internal Kubernetes clusters. And we use Artifactory to store the things we build and things we download from external sources that we need to use. And for monitoring, we have Prometheus, Grafana, and the Elasticsearch, Logstash, Kibana stack. And in all those areas, we have spent quite a lot of time, and quite many years actually, to build automation and making sure that in every step it's as easy as possible for a development team to set up a new service or change service and push it all the way to production. And being a small group, like the three of us, tasked with finding out how we can run AI and make great use of that internally. We, of course, want to reap the benefits of this infrastructure that we have as much as possible. So with this security part saying we need to run internally, we also had a strong incentive to try to pull what's usually found in the Python world when it comes to AI into this world of Java. So that was also a main objective when we started this work. But of course, we need something more. We need hardware as well.
Yes, and everyone knows that AI needs GPUs, right? Well, organizations usually don't have rows of GPUs just lying around and waiting for something like the AI revolution. And we also know that they're very expensive. And to buy expensive things, we need a solid business case. And of course, with the cost, we also need to usually prove some value in, say, a few proof of concepts. But doing proof of concepts with AI services and technologies, we usually need GPUs. So we find ourselves trapped in this chicken and egg situation. How can we break out? Can we break out? We've been running here for a couple of months at least before we actually figured out that some models don't need GPUs. Some can run solely on CPUs, and with the right use cases, we can design around this hardware that we don't have. But where do we start?
Yes, aim to prove a bit of technology running in your infrastructure, on your environment. And to trigger the interest of the organization, make sure that you address a real business need. And design a small case around it, something that will benefit a small set of users, but where the results can be explained in such a way that a large part of the organization will understand it. And then don't do a proof of concept. Make a full production-ready implementation. Engage whomever needs to be engaged and bring it to production. That is where, as we have said numerous times already, where you will find the real value.
We'll talk about two cases today in two areas where we've been working with internally running LLMs and also with specialized machine learning models. So we will go into details in each case representing one of these areas.
And in the first case, we wanted to prove that we could use an LLM, one of those open source LLMs that are out there, like Meta's Llama 3 series or Google's Gemma 2, and run it on the available open source components, but inside our data center. And the hypothesis is that there is enough stuff around out there that is make it possible for us. And the first thing we found was a llama. I think you've heard of it a few talks before, but it's a platform where you can pull those models down and run them locally on your computer. It also turns out that the llama can be packaged as a Docker container, which make it fit not only on the local PC, but also in our Kubernetes cluster. And it has a web interface or a REST interface. So it seems quite good. And then, as we rely so heavily already on Spring, why not keep it in the family and start looking at Spring AI for integrating our Java services? So that's where the components that we started to use in this case.
And for the business need, we, as many organizations, get comments from customers, citizens, and we have multiple channels for receiving comments and lots of processes internally, of course, to taking care of this, because they're very important to maintain and develop our business, because we're here for the citizens. And for this use case, we got the question if we could help out to summarize and classify comments specific to one type of channel, so that the business could be able to see if AI could help out with new type of material for doing a new type of analyzing for the business. So this was a really good small, as we talked about, small use case, and really good because we could run it as a batch job, so no one has to sit around without our GPUs. So let's dig into what happens behind the scenes.
Yeah, we need to look at some architecture, don't we? So this is the beginning of a C4 model with container diagrams. And I will use that to walk you through the setup that we're currently running. So we have Ollama on your right. And when you download Ollama and install it on your computer and start it up, it will create a disk area for itself where it can store downloaded LLMs. So that's what we have here in the Kubernetes cluster. That is just a file area we give it access to. The Ollama project not only produced this software where you can run, it also packaged lots of models, lots of different open source models that are packaged up, so it's really easy to download them. You can just pull them down and run them on your local computer. And they are published in this Ollama model repository. But that, of course, means that you need to have an internet connection. And when running inside our data center, we don't want any random service to call home and have access to the internet, of course. So we need a way to get those models internally in our network. And luckily, Ollama also has a Windows version. So you can take that Windows version and run it on this computer, actually, the normal office computer, and that system administrator happens always, or most of the time at least, to be me. So I can download, not run, but I can download the models we want, and I can push them up into a repository in Artifactory, which of course is available to our services. So that way we bring it internally. But it's also so that this API between the Ollama software and the Ollama register is treated like an internal API by the Ollama project. And considering the actual use case for Ollama, that is not so strange. It's okay decision, and they can change this as well because they don't publish it at all. But it created some problem for us this summer when I think due to more interest or in other ways increasing load, they decided to move the files off that model register and put it onto a CDN instead, and just have the register return a 307 redirecting to where the files actually were stored. And they took it so far that when our Ollama instance was talking to Artifactory, and of course got an OK 200 back because the files were actually in Artifactory, it said, no, I can't download this. I need to have a 307 temporary redirect. So we created an internal small proxy for this. An internal Ollama model library that's only there to mimic the external one and give that 307 pointing to the file in Artifactory. And that way we got it working again. And we also got some benefits from that, because now we can store the files in Artifactory in whatever structure we want and not have to be exactly as Ollama expects it to be. And I like to believe at least that this gives us the opportunity to handle any future changes to this API as well. But I've said a few times already, Ollama is designed to run on your local computer and use GPU if you have, otherwise CPU. But when you run it in an enterprise setting, there are a few things you need to consider. First thing, there is no security whatsoever in this product because it's running on your computer, so you don't need it, right? You have all the access you need. and you should be the administrator of that one. Not quite how you want it to be when you have multiple clients talking to you in instance in production. It also has this REST API, which is good, of course, but it's very broad. You can pull new images, you can delete images, you can change whatever setting affecting the whole instance, and you don't want really that either in an enterprise setting. And there is no request throttling, which means that, especially since we run on CPU, it's really, really easy to overwhelm this instance with queries. One is enough for that guy. So that we need to handle. And in the future, it might also be interesting to be able to do load balancing over several instances, for example. So we should need some sort of clustering, but no, it's not there either. So once again, we decided to implement something on our own. We put up what we call an LLM portal, and we just banned all external access to the Llama instance itself. And any application that would, normal Java application that would sort of use the LLM would go through the portal instead. And since we were using Spring AI has an integration towards Llama and lots of other providers as well, but since they have that, they also have an implementation of the data classes that are part of that Llama API. So we could use that to create or re-implement the part of the Llama API that they actually wanted to publish to the rest of the agency. So it was quite neat, and through that we've been able to implement some security with requiring an access token to run queries. We can do request throttling by sort of having a queue in that portal, and we actually also created a small twitch to the API where we have an async API where you sort of post a job and then you can pull it to query it to see if it's ready. Another way to work around this CPU problem. And in the future, we think we can use it to implement load balancing over several instances. We can use have logging, for example, and we can have prompt filtering, all those security measures that we heard of this morning in the presentation. Well, so that is pretty much what we have right now, and that enables us to do and deliver this use case that Maria was talking about. And as we did, we learned quite a bit, didn't we, Julius?
I think we did. And the most obvious one is that Llama can indeed run LLMs on CPU-only nodes in an enterprise setting. We used our standard nodes with 8 CPUs and added more memory to reach 80 gigabytes, which is sufficient to run the Llama 3.3 in a 70B configuration. But it is slow, really, really slow. A comment of about 4,000 characters takes roughly 15 minutes to process. And as Jörgen said, multiple requests in parallel makes it even slower. Hence the request throttling. So we know that we have to focus on tasks and use cases where we can run these jobs asynchronously so that no one actually has to sit around and wait for the LLM to answer. We tested a lot of models, different sizes, different vendors, and we quite quickly realized that the smaller models, around a few billion parameters, they struggled quite a bit with Spring AI's JSON to entity feature, which is a way of converting the output to a class in Java. And we also realized that, yeah, the larger models are quite okay at working with Swedish text, especially if you give it a Swedish prompt and Swedish instructions. But we have not yet tried more complex text from our internal documentation. That concludes the first case, and we will now move on to the second one, where we will talk about the niche machine learning model.
And here we wanted to deliver customer value by handling these handwritten citizens requests. This is an analog submission form, and it will be used just for a limited duration of time. However, we think we're going to get up to 15,000 submissions. So we discussed a lot internally, of course, that it was necessary with an automated solution. And this solution ended up being a mix of technologies, where we had machine learning, but also mathematics, we'll come back to that, and low-code software to making the business rule validations. But today, of course, we're going to focus on the machine learning part.
And the submission, it contains handwritten digits, standing for a year, month, and sometimes a personal identification number. We also have these checkboxes that we need to identify whether they are ticked or not. And we need to interpret these digits. The automated solution is estimated to be able to handle at least 10 times more submissions per minute than the manual procedure, considering our limited resources. The natural place to start when solving a problem is to look at what has already been done. And Hugging Face is one such place when it comes to AI models. We want to look for a model that solves a task that is as similar to ours as possible. And however, using multimodal LLMs is currently out of the picture due to the significantly higher resource demand. When we browsed Hugging Face, we ended up looking at a model from Riksarkivet, the Swedish National Archives, which is able to perform single-line optical character recognition. And this model has been trained on handwritten text in Swedish. And the underlying architecture was originally developed by Microsoft. Unfortunately, we quite quickly realized that this model is not good enough at interpreting digits, which is what we actually wanted. And therefore, we looked into the task of fine-tuning this model, since it's quite small. Then comes the problem of data. We have no available data, and gathering real-world data is very expensive. So we decided that, maybe we can generate data. Looking at the MNIST dataset, which consists of handwritten digits, a lot of images, we figured out that maybe we can use this and stitch together a lot of images and in that way create the data for the relevant fields that we need. And we do this in a way that we try to increase the diverseness of the data. So we randomly sample each number sequence, we randomly sample what image to use, and we keep track of how many times we reuse each single-digit image in order not to overuse them. And we also randomize the size and the placement of these digits, as you can see in the images to the right. Fine-tuning this model gave a significant improvement in performance, and the baseline model achieved about 10% accuracy on this generated test data, whereas the tuned one reached about 98%. Generating this data, fine-tuning the model, and evaluating it was all done in Python, using mainly NumPy, PyTorch, and the transformers library from Hugging Face. But Jörgen, how do we take this into the world of Java?
Yeah, that's a question. I mean, training a model, or in this case, downloading and fine-tuning it, running on a workstation, that is one thing. But the real value comes from pushing it to production and actually start using it. So we need to lift it out of that Python world and into the Java world. And then we have something that's called Deep Java Library. That is is a Java library that is meant to use for executing models. It also has an API for training, actually, but we used Python for training. So we didn't try that from Java. But it has a thin Java API, and underneath that, it's all C or C++, C, I think, implementations for the different model or the different types of models. And they call it engines, and they are packaged up like Maven or graded dependencies. So it's really easy, even though it's so much C code, it's really easy to just put that dependency in the POM, and it will be pulled in, and you have everything you need. So there is one for running PyTorch models, another one for Onyx, or for the Google one.
TensorFlow.
TensorFlow, thank you. So in this case, we had a PyTorch model, and it turned out that the engine for that wasn't quite comfortable with running the more advanced models, which our model happened to be. So we found a tool on Hugging Face as well, where we could convert it into the Onyx executable format instead, which, if I'm not wrong, is a sort of an open standard for exchanging this type of models, developed and shared by Microsoft, actually. Anyhow, by doing that conversion, we could use the deep Java library to run the model, execute the model inside one of our normal Java Spring Boot web services. So from the outside, this web service looks nothing different from any other service we produce. The only thing it has is it downloads a zip file with this model internally, and it runs the ML execution there. And then we have some learnings, right?
Of course, we have. As we heard, it worked to port the machine learning model to Java. We had, of course, to learn it, but it works. We also learned that CPU actually lasts longer than we expected. And in this particular case, the one calling the AI service can even use the CPU resources we have. So we cannot maximize what we have for CPU right now. So this is a perfect solution, probably will be running on CPU when we get GPUs. But we also learned that all parts doesn't need to be AI for an AI solution. And one example is that we calculated the proportion of colored pixels for the checkboxes to determine if it was ticked or not. So it's getting a bit old, but it's still relevant with keeping it simple. It was a lot better than just training a model for that specific little task for this submission form. So it was a good example for not all parts need to be in AI. That summarizes our two cases and what we've done. We've succeeded in both of these areas, and we have the architects to continue building with new business use cases. And the question is if it will work for everything. Have we found a silver bullet, Jörgen?
Yeah, no, we haven't. I think we might even be in for a technical disclaimer here, because what we have shown you, what we have sketched up here with our solution, is something that works for a lot of models. We have tried lots of them, and we've found some of them working, some of them not. But the reality is that there are loads of models out there, loads of different architectures, and probably, or I would say certainly, not all of them will be runnable on these two technical stacks that we have shown you here. But still, it's so many of them. The selection of models is so large that we feel that this is kind of good enough. We will probably be able to find models that can satisfy most of the use cases we will encounter. The biggest bottleneck right now is, of course, the compute and the hardware. But looking at this, there might be a bottleneck in the future. We might run into some use case where we need a model that can't be run using these tools that we have. But that would be another story in that case. So pretty good, but no silver bullet, of course. But even more importantly, actually, is that we have only had like half the talk so far, and we talk only technology. But when we start to talk about AI and bringing AI into the organization, there is a huge sort of shift going on also in the organization, in every part of it. And I think we should spend some minutes talking about that as well, because that's where we have seen lots of learnings, right?
Yeah, I completely agree. AI is indeed more than technology. And as we get our solutions closer to production, we see that we engage the organization in a new way. The learning is accelerated, and more people engage in both discussions and decisions regarding our operations and our data. And as developers of AI-based services, we need to know the structure of the data that is at the heart of the problem we're trying to solve. And we also need to have access to a few examples. Another thing to consider is that this is a new way of thinking. We have the possibility of new types of solutions. Solutions that cannot be solved by normal programming. In order to solve a problem using programming, you need to be able to specify a step-by-step solution, an algorithm. However, trivial tasks for us humans, such as recognizing a written digit, is almost not possible to write an algorithm for. And this ability we have to recognize that the two is indeed a two is something that we learned as children by looking at lots of examples, interpreting them, and receiving feedback. The same process we use to train our AI models. However, business users have been told for a long time that in order for us to be able to automate their work, they need to be able to specify in detail how they perform it, so that we can design and program an algorithm for it. With this new technology, we all need to retrain our brains to be able to jump out of the box and to start thinking of how to solve also those problems that cannot have an algorithmic solution, because that is where we will find the most value of using AI.
And in any even slightly regulated context, you need transparency. You need to be able to go back in time and say why a certain thing happened the way it did in an IT system. For an example, we have to be able to tell why a specific payment was paid out the way it was. Maybe years back, but we need to have that traceability. It doesn't matter if it's a human-made or an automated decision. We need to have that traceability for it. And with traditional programs, we can do this by applying a versioning control and just keeping track of what version is in production at what specific time. Then we can go back in time, we can read the code, and we can reason about why did this computation take this specific flow. But with AI, there's another story. Because no one, not even the one who trained the model, can say why the output of a certain input is the way it is. Or not even foresee the output without actually running the model. So we need to be able to store the input and the output to save the execution in somehow. Because that, with the surrounding code, will make us have the same traceability to be able to reason about why it ended up the way it did. So that's also a new way of thinking of how do we keep the same level of traceability. And AI literacy is something also we mentioned, but there are lots of people more than tech that needs to dive into what does this mean from my perspective. And one example of this is that we had the legal department reading the AI Act that was published last year. They read it when it was published. We didn't have an AI service coming to production, but they read it in a high level, just to understand how could this affect us when it starts to be something we need to take into our consideration. But now that we came knocking on the production door saying this is what we want to production, they had to read the AI Act again. For this specific case, with the specific questions, and it was really good discussions going into the details. So this is also something that you dig lots of deeper into when you're closing up to production. But maybe the most important part is the organizational commitment. Because if you don't have the demand from the business, it will be very hard to reach production. We need to have the commitment from everyone to get the resources and the priority we need. If we're only having the drive from tech, and we don't reach production, we won't be able to create the value that we're striving to put into for customers or internally, of course.
Yeah, and with that, it's time to wrap up this presentation and try to summarize a bit to just give you some good things to bring with you as you leave us today. First thing we learned, not all AI require GPUs. Yeah, it will be slow running on CPU, but we still can do that, and we can start this learning process, and we can start creating value. And if we just select the right use cases, we can design around that to embrace the asynchronicity, for example, and not sitting around waiting for the LLM to answer. So we can start even though we don't have GPU. We still don't have GPU. We hope we will get that this year, perhaps, we'll say. But still, we're running. And also, AI is so much more than those large language models. Yeah, that's the hype. That's what we've been talking about for 2 or 3 days straight now. But AI is so much more. We still have that old or traditional technology of machine learning with smaller, more specialized models that work many times as good or even better if you have the right model for the right use case. And also, not all problems are AI solvable. Or they might be that they might not be suitable for AI. There might be a simpler solution. As Maria mentioned, the checkboxes. I mean, training a model for just seeing if a checkbox is empty or not. No, but with a mathematical solution, it wasn't that many rows of code actually to do that. So that is also something we need to bring with us into this hype when we start to do something with it. There is a lot of value in AI, but not all problems should be solved with AI. And then it's more than technology. We need to do this together with the business, because if we only try to drive the AI adoption from the technology side, we will run into lots of problems. And there is a process for the organization, from legal to security to changing how people work in the production side of the business. Everything has to go hand in hand. So, but doing it from a technology perspective, starting it because we see the possibility, is one way to start provoking that change in the organization as well. And that is what happens when you make it real. When you find those small use cases that you actually can implement and take to production, that's when you make it real. That's when everyone understands that, okay, now we're not only having a theoretical discussion of how AI will affect us, now it's something that is actually happening, and we need to understand and do something about it. And remember, the prerequisites are there. You don't have to wait for the organization to be 100% ready. because it will never be, or for GPUs to be available. They will eventually. Assemble the team of the diverse skills you need. Start small, do it today, and find that business need that you actually can fulfill with what you have to get some sort of motivation and start to build the software you need for bringing the value out of AI. And with that, thank you very much for listening. And
great stuff. Great stuff. Thank you, Jörgen, Maria, and Julius. And please don't forget to rate at jfocus.se/. Come on, you know this drill. jfocus.se/. Great. And maybe we have some time for, you can use the QR code here as well. But you have some more time if you want. Anyone that has a question?
Yes, thank you very much for sharing the adventure. It's really inspiring. Like, if a highly regulated Pensionsmyndigheten can do it, I guess we can do it as well. My question is, have you considered to use off-the-shelf GPUs, like the consumer-grade GPUs?
Yes, but not in reality, because we are an agency. I used to say that we are quite small, so we can sort of make things happen in the organization, and we're quite big, so we have some funding. But that also works the other way around. We're so big that we need to adhere to how we run our data centers. We can't have a AI server running in the basement. It needs to be in the data center. It needs to be properly handled. So unfortunately, we're a little bit too big for doing that. Otherwise, that would have been really nice.
Good question. I think there was another question.
Hi. Hello. Hi. Thanks for the talk. I have a question about SLA. Have you considered your service level agreement when you're adopting the AI technology in Pensionsmyndigheten? For example, in your case, your machine learning model, you have accuracy for 98% approximately. But maybe you should consider even a bit higher about this data correctness, because anyhow, it's a person's person number, and people really want to get help from you. And also regarding the application-wise, have you considered like using AI can bring you the efficiency that can improving our speed, lower down the costs, those kind of SLA? Thank you.
Thank you. I think it was more than one question, so we take them one at a time. You go with the first one, right?
Yeah. I completely agree with the accuracy part. However, the part we didn't mention is that this is only for the model. So after the model, we do all the accurate, or we do a lot of checks, like business logic checks, to make sure that the all the values make sense. And if they don't, we give it over to the manual procedure. So we will never reach 100% with anything. So it's important to be comfortable with accepting some level of uncertainty. But that also means that you will have to build systems around it so that you capture those cases where the model makes a mistake.
And I think it's important to recognize that with all AI models, when you use ChatGPT and you get an answer, you have to evaluate that. You don't blindly follow what ChatGPT tells you to do. You evaluate depending on the context and whether this makes sense. Just because it tells you to delete your files, you don't do that because you think that they are quite valuable. And that type of filter, we will always need that. In this case, we have some normal code running around it to make sure that the personal identification number we find out is actually connected to this person, and a lot of different checks. Yeah. So that filtering is important, but the model itself can probably not be much better than it is. And then the second question was about more other use cases to save time and money?
This is the interesting part. Of course there is. I think we're going to find them, but I don't think that's where we're at. When we talked to someone, we were in a meeting just a couple of weeks ago, and they wanted this. Well, this is going into production, but they wanted this. So today we have to just take it down to smaller bits and pieces, and saving time is the most important part we're talking about. Saving time in the manual procedures so that the one who's done an application or a submission form can get their money as soon as possible. So we're talking mostly about saving time when we're doing it. But since the technology is new, we're trying to take it down to, okay, can we the AI part, can we do it for this submission form that, I mean, 15,000 is a lot, but it's not a lot compared to the numbers of pensioners in the system. And can we keep it, okay, can everything go to manual handling? Yes, it can. Okay, then we can do this. So I think we're going to see lots of cases aiming for saving time. But we're trying to keeping it small, and taking as much as possible into the classic programming, of course.
Yeah, but it also, I think it was you, Julius, that talked about, you know, the dog popping out of the box, that we have to start thinking and have to train the organization also to think in another way, because what we see when we talk to the people in the business is that either they are so focused on the problems that we from IT have usually been able to help them solve, like those things that you can say, do it this way, then this is where you can define the algorithm. Or they do, as Maria say, they have this vision of a chatbot that would answer all the customers' question and give them advice on how to spend their pension. And the truth, and I think the real value that we actually can deliver, is somewhere in between. So a lot of the learning we're doing right now, aside from the technology, is to start finding that value.
And another one here.
Thank you for sharing your experiences with us. My question is, you mentioned you did some model training in Python side, and then you moved into Java. Have you considered using GraalVM's Python implementation to do that, like keep everything in the JVM side?
To keep all on the GVM side, like doing the training there as well?
Yes.
You mean, yeah. No, but that might be something that is interesting to have a look at, because at some point, I think we might want to train models that don't fit for training on a workstation, that we want to push onto the GPUs that hopefully is there someday, and then that might be a way to go, because then we are more restricted in what way we can run it. So yeah, thank you for the tip.
Because in that case, you can just do everything in Python and not have to worry about moving to the Java side, because you can communicate, like in the same VM, you can just pass around the data or the result, make the Python implementation do all the heavy lifting, and you just get the result and use Java as a server-side language.
Ah, okay. Now I see. So then it's more about execution.
Yes.
Yeah. Okay. I don't know if at least from what we have seen, if there is so big difference, because the things you do in Python tends to have a C implementation under it either anyway, right?
Yes. Usually, or for all of them, are C libraries wrapped in Python code.
Yeah. So C libraries wrapped in Python code or C libraries wrapped in Java code might not be such a huge difference when it comes there. I think the most value out of the Python world is the training utilities you have there for handling all the data and running the training, right?
Yep.
Yeah.
And it's also a factor of that. When we met like half a year ago, I didn't know any Java programming more than what I learned in school more than 10 years ago. And you didn't know any machine learning or AI development. So we have been trying to bridge our two worlds and slowly reaching into a world where we have some understanding of each other's concepts.
The whole purpose of the GraalVM's Python project. So since it has a very rich set of libraries, you use the full potential of it, and you just bring back all the results to Java.
Yeah. We will look into that. Thank you.
Thank you. Thank you very much.
If there's any more questions, we'll stay around here for some time, and thank you for listening.
Thank you.